All right, and then today we're going to talk about how to name the substituents. So yesterday we had exactly the same molecule, and we said the longest, the parent chain ran through like that and was, if I'm not mistaken, 7 carbons long. So our parent chain was heptane. Okay, and we numbered our carbons starting here because it was closest to a substituent. 3, 4, 5, 6, 7. Okay, you need to do this step before you can start to name your substituents because we need these numbers and we need to know what's a substituent and what is part of the parent chain, because these carbons that are part of that parent chain, we don't have to give them any other names. They are already taken care of in this heptane. So now I need to go through and give each of these things a name. So the way we name substituents is we give them a number that tells us where it is on the parent chain, and then dash, and then a prefix that tells me number of carbon atoms in the substituent. I'm going to abbreviate that, okay? And then, sorry about that, and then it ends in a YL, okay? So this right here, this substituent, it's on the second carbon, so we call it 2, okay? And there's 1 carbon in the substituent, so this is a meth, is the prefix for 1 that we've been using, and then it'll end in a YL, okay? And then this substituent right here is on the 4th carbon, so we call it 4 dash, there's 2 carbons here, so that's F YL. So this is a 2-methyl group, this is a 4-ethyl group, and then I have this one over here, which is a 5-methyl again, because there's only 1 carbon in that circle. Okay, so I encourage you to draw these circles, draw the line, draw the circles. By the time you're done, you should have every carbon either part of the line or in a circle. Okay, I encourage you to be really careful. If you think you have something like a propyl group or a butyl group, or if you think you've got a pentyl group, you probably have your longest chain wrong. Very rarely will we have anything much bigger than ethyl. Prop, sometimes you'll have a propyl group, but most of the time you will only have methyls and ethyls. Okay, let's do one more like this. Should we take the one? Let's go ahead and take this one I had from yesterday. Oh no, those are all never mind. Those are all methyl groups. We don't want to name those. Oh, let's try. See if I can get one in here that has a propyl group. Yeah, that do. Okay. So we have this one here. Again, we find our longest chain, which should run here to there. Just like we did yesterday, you still need to count them. 1, 2, 3, 4, 5, 6, 7, 8. So this is octane. Okay, and then you number them. So here it'd be 1, 2, 3, and here it'd be 1, 2, 3, 4, 5. So we go with the 3. 1, 2, 3, 4, 5, 6, 7, 8, and then we give a name to each of our substituents. So this one right here, it's on the 3, and it is a methyl, so this is a 3-methyl, and this one right here is on the 4, and it has 3 in it, so it is a 4-propyl. propyl. And actually, there's one more thing I want to show you, something I kept thinking halfway through that one and forgetting about. So what if we had something that looked like this? Yeah. Okay. First problem, parent chain goes conveniently straight down. Now, could I go up in here? Yes, it would be the same. But let's take the easy one. So that's 5. That's a pentane. It's not an E. Okay. Which side do we number from? Well, if I go 1, 2, 3, I end up 3 there. If I go 1, 2, 3, it's 3 there. It doesn't matter which one it is, so it doesn't matter which way I count. 2, 3, 4, 5. Okay, now naming these substituents. I do not have a string of 3 carbons sitting here on this 3. What I have is one string with 1. I'm going to name these two things separately. This is a 3 methyl group, and this is on the 3. This is a 3 ethyl group. They are two separate things. They don't like get added together because they're on the same carbon, because they're not attached to each other. Something that's going to be a propyl group will be actually a string of 3 carbons attached to one center one. Okay, that's all there is to that. And tomorrow we will look at then how do I take all of this information and put it together into a big, really fancy sounding name.